Welcome. I'm really glad to see everyone after many years, finally getting back here in person. My main contribution over the years has been to develop camera systems. I've been doing that, stereoscopic camera systems, which I've been doing for about 50 years now, I think. But most recently, medical systems. I had a company that made cameras for surgery, surgical microscopes. And this work has kind of folded out of what I was doing there, because the next stage after doing the surgical microscope, I wanted to do a low-cost stereo microscope for all the other stereo microscopes that exist in the world. There's stereo microscopes are used in the industrial world, obviously, in the scientific world, in other medical procedures that are non-surgical. There's a whole plethora of different applications for stereoscopic microscopes, and they could all use a camera and they could all use a screen instead of people putting their eyes up to the eyepieces. So I had started another company to try and get the cost down, and one roadblock we ran into was the display. The displays are that we were using are very hard to get. So I discovered Peter was developing a low-cost display and got together with him. So what I'm going to talk about is that we've been able to do time sequential on OLED monitors. That's basically our bottom line. And so if you've got other things to do, you could go and do your other things and come to the demo, though. We'll have a system set up at the demo session this afternoon, and you'll see that it's spectacular when you do it on an OLED monitor. So this is a somewhat new implementation of an old idea. The time sequential, which of course has been done way back on CRTs and then on LCDs, but there's always been issues on LCDs, and you'll see that we've resolved those with the OLEDs. So let me dive in. I just put up a slide reviewing the current status of popular 3D flat panel displays. There's four main categories of technology. There's a direct view, time sequential, micropolarized, which is the interleaved technique that has become a standard for high quality. It's used in medical systems. That's what we were using in our medical system, but of course those have become more expensive, hard to find. And one big issue that we have with the interleaved technique is as you go to higher resolution displays, there's two problems. One is it's harder to make the filters to match the rows on your display. And the second thing is you lose the viewing zone. There's always a restricted viewing zone that gets worse and worse as you go to finer pixels on the screen. So I don't think there'll ever be an 8K. We have 4K interleaved monitors now, and we've already lost the vertical viewing zone. And it'll get even worse if you try to do an 8K display. So we need something else. And that something else is the OLED display. So let me move on and just, you guys probably know a lot of this, so I want to go pretty fast. On an OLED, let's see, do I have a cursor here? Yes. The OLEDs, of course, switch very fast, faster than the CRTs used to fast. The CRTs had a fast pixel response time because of the beam that illuminated the phosphor, and the phosphor would decay as soon as the beam went away. But on LCDs and OLEDs, the electronics is a sample and hold electronics. Instead of there being a pulse of illumination, it stays on for a while. We call that the persistence time. So the persistence time is going to be based on the frame rate and not on the response time of a pixel. So unfortunately, with the OLEDs, even though they have a very fast pixel response time, they did not build the electronics to take advantage of that. They did it, they still use the same sample and hold techniques, same electronics. So the problem is that combined with the fact that we're scanning from top to bottom, and no pixel is replaced until the next scan comes in, you can have your two images on the screen at the same time. So you want to do left-right alternatively, but now you've got both images on the screen at the same time. This is nicely illustrated in a paper written by Andrew and his colleague. I'm not sure how you say that, Andrew? Sitchik. Okay. And they have some nice diagrams in this paper, which is the time-space domain. And at any slice of time, if you try and make, where's my cursor, a vertical slice of time here, you can see that you never have, this is for an LCD monitor. The example here, this is just an example running at 75 frames per second, that you never have a clean black or white image on the screen at the same time. So you've got to figure out a way of basically turning off the pixels and defeating the sample and hold. And this has been done on LCD screens, but it's rather difficult, and there was a boom, of course, when people were trying to do this and sell time sequential on LCDs, and in particular, NVIDIA was influential and created a light boost technology. This is basically strobing the backlight. That means you need coordination now between the timing of your images, basically the software, and the hardware. In other words, you need to have the manufacturer provide the right type of strobing backlights that would work. And if you do it right, you can get some very good stereo images with very low ghosting. But it's difficult, and basically that technology has gone away. NVIDIA is not supporting it anymore. There are still some LCD monitors out there that have a strobing capability, but they're not generally available, and you'd still need special software in order to control those. So Andrew and his colleague did another example where they did try to illustrate and test the a black frame insertion. So if you can boost your refresh rate and insert a black frame, that's a way of turning off the pixels and getting more a cleaner switching between the left and the right image. So you see that in this diagram, things are happening faster and it's better, but even in this diagram, if you try and find a vertical slice here that just has a clean left image or clean right image, it's not possible. So we have found that the black frame insertion does work very well with OLED displays. Sorry I don't have a good illustration of this, but what's happening is they're switching much faster, and you get a clean break between the frames, but you still do need the black frame insertion. And there are monitors available these days that actually have it built in. So we're very fortunate that they've gone back. I should mention that the driving force for having this type of display is actually the gamers. The gamers want to see very good motion without any blur. This motion blur is a big problem with the LCD monitors, and these techniques have been developed to help in that world. But it helps us too, so that's great. So they are reasonable cost, these monitors, so we're able to put together a system that does bring the cost down. If you have a monitor that does not have the black frame built into it, black BFI built into it, Peter has shown, he's developed some software that inserts a black frame. If you have a high frame rate monitor, then you can go ahead and insert the black frame yourself. So what Peter has developed, in addition to doing the software that's necessary for this, is a synchronization system. This is an idea that's been around for a while. We don't think we can patent it, so I feel free to talk about it. But this is a means of picking up a signal from the image itself in order to do the timing, the synchronization with the glasses. And not only does he use a photocell to pick up a little postage stamp, as we call it, that's embedded in the left image, but also his little box here that we call sync, with all caps, of course. Not only does it pick up the postage stamp, but also, gotta move. It sends a white light signal that will interface with the DLP glasses. Peter, you want to come up for a minute? I'm going to ask him to say a few words about the other software that he's developed.
Awesome. Thanks, Mike. Great. Hi, my name's Peter Giocaris, and I'm going to go over the software part of the system that drives the sync box that I had created. So I effectively I just used Unity because it was the easiest approach to actually build, software that I could drive the hardware with. And effectively, if you don't know what Unity is, it's a development platform that allows you to build. Yeah, there we go. It's easier like this. It allows you to build applications for different cross-platform applications for different targets, Windows, Linux, Xbox, etc. So I'm currently building in Windows, and I've created a Unity integration package. What that does is it allows you to take all the scripts and binaries, anything that's required to drive the system, to give a person an example of how it works, and you can put that into your project. You can basically inject it into your project, and then you have the functionality to start using sync. So from there, I've created a bunch of different applications. Simple Scene, that's one that's basically a bare bones project. So it shows you how you can actually use sync in Unity without any content that's maybe copyrighted. And then Simple Scene Plus has 3 enhanced demo scenes, which we'll be showing this afternoon, to give an example of what 3D looks like with really nice content. And then Monkey Shines was a complete game that was built specifically for sync. I actually had a contractor to build it for me because I really wanted to play a game that was built, that encompassed all the what I feel sync shines in. So, and there's also another AA style game that is built in Unity that is called the Explorer. And I'm not sure if you know that actual project, but it's literally a platformer, 3D platformer, and I was able to integrate sync into that. I created a 3D movie player so that you can actually play pre-recorded 3D movies from your iOS or movies from anywhere, using a streaming system that has been used by many different applications. Just a side note, I've also been able to create 48 frames per second high frame rate movies using AI interpolation on 24 frames. So you can I can show you like a couple of those, like Tron Legacy or Avatar, in 48 hertz, which is kind of nice. And then finally, there's a 3D Paint program that I use to show how it could be used as an for creative applications as well. Thank you.
Thanks, Pete.
Yep.
Peter. So that's it. Please come and see the demo in the demo session.
Okay, thank you.